it might be nice to know that we can find other roots. We can take other radicals. So since we can do more than square a number, right? We can square a number, cube a number, raise it to a fourth power. So can we take a cube root and a fourth root, etc., right? 2 cubed is 8, so the cube root of 8 is 2. 2 to the fourth is 16, so the fourth root of 16 is 2 as well. Negative numbers can have square roots, but their roots are not real numbers, as I said earlier. We will not consider the square of even roots of negative numbers in this class. I don't want to see any square roots or even roots of negative numbers. But it's important to note that with odd numbers like cube roots, negative numbers are okay, right? If I have negative 3 cubed, that's negative 27. So the cube root of negative 27 is negative 3. I can undo that. So we can take cube roots or odd roots, odd number roots like fifth roots, seventh roots of negative numbers. Let's talk about the order of operations. In mathematics, this is how we determine how to approach an expression and how to simplify it. So you probably have heard of PEMDAS before. This is the most commonly accepted version. It stands for parentheses, exponents, multiplication, division, addition, subtraction. It's remembered with the mnemonic, please excuse my dear Aunt Sally. But here's the thing. Multiplication and division and addition and subtraction were meant to occur at the same time from left to right. When you're given an expression, to solve it correctly, you don't first go through and do all the multiplication and then all the division. You do the multiplication and division at the same time from left to right, and the addition and subtraction at the same time from left to right. So there's been this new movement to accept a new term, a new acronym. This is an acronym of GEMS. And that stands for grouping because we don't always have parentheses. Like grouping can also be brackets. It could be absolute value bars, and it could be parentheses, right? So it means grouping symbols, exponents, multiplication and division from left to right, and then addition and subtraction from left to right. So as you're going through an equation from left to right, you do multiplication and division at the same time. So I personally think it's better than PEMDAS. So we've got grouping, exponents, multiply, divide, subtract, add from left to right. It includes more grouping symbols other than just parentheses, and it leaves the fact that multiplication and division, and it does state that multiplication, division, and addition and subtraction occur at the same time from left to right, just in the same direction that we read. So let's work through some examples. So the first thing, G, grouping. Are there any grouping symbols? No. Next, I'm going to work from left to right, doing multiplication and division. 9 times 4 is 36, minus, we don't subtract anything yet. Now we divide. We've got division over here. 8 divided by 2, which is 4. 36 minus 4 is 32. Next, let's take a look at problem 2. Are there any grouping symbols? Yeah, there's a ton, but none I can get rid of right now. I've got an exponent, so that gives me negative 3 times 5 squared, which is 25. I should have just written 25, right, because we got rid of the exponent, minus negative 2 times negative 8. Now I'm going to go ahead and do division from left to multiplication and division from left to right. Negative 3 times 25 is negative 75. Minus negative 2 times negative 8, that's going to be 16. That'd give me a negative 91. Negative 75 minus 16 is negative 91. For problem 3, I have negative 4 minus 3 times 5 plus 6 squared, so let's take care of that exponent first. Next, I can do my multiplication. Now I can go ahead and subtract and add from left to right. So negative 4 minus 15 is going to give us negative 19 plus 36, 17 would be our remainder. All right, for problem 4, I've got my grouping symbols. I can simplify this. Negative 9 minus 5 is negative 11. So I have the absolute value of negative 11 times negative 8 plus 3 squared. Absolute value of negative 11 is 11. 11 times negative 8 plus 3 squared. 3 squared is an exponent. We can turn that into 9. That gives me negative 88 plus 9, which is negative 79 is our final answer. So let's do a couple more complicated examples. I have negative 9 plus the square root of 16. That gives me negative 9 plus 4 times negative 3 squared over negative 4 minus 1, which is a negative 5. Negative 9 plus 4 is negative 5. Negative 5 times a negative 3 squared is a positive 9 over negative 5. That gives me negative 45 divided by negative 5, which is a positive 9. All right, let's check out this numerator. I have 2 times negative 5, which is a negative 10, plus negative 3 times negative 2, which is 6. I've got negative 8 plus 9 minus 1. That gives me negative 4 over negative 8 plus 9, which is 1, minus 1. That's negative 4 over 0. This is undefined, or no solution, because we can never divide by 0.